All right, today we are doing 6-4, proving quadrilaterals are parallelograms. As long as one of the following, is true, then the quadrilateral is a parallelogram. So first off, both pairs of opposite sides are parallel. So the top and the bottom must be parallel to each other, and then the two sides must be parallel to each other. Both pairs of opposite sides also have to be congruent. Both pairs of opposite angles are congruent. So this one is congruent to this one over here. This one is congruent to this one down here. Okay, remember congruent is the same. The diagonals bisect each other. So that means when I draw diagonals through here, we're pretending those are really straight lines, okay? This half is congruent to this half. And this little half is congruent to this little half. Okay? And then two opposite sides are both congruent and parallel. So in the side on the right, you don't have to write the 5 statements because they're already written on the left. You're welcome. So that part right there. So now let's look. Which quadrilaterals are parallelograms and why? Okay, so we have these two these two angles are 63. And we need to know what this angle is. Well, that's 117. How did Miss Reidner get that? Well, I know that a straight line has 180 degrees, and so I did 180 minus 63. And then I know that a 4-sided figure should have 360 degrees total. Okay, that comes from 6-1, the 180 times the quantity of 4 minus 2. So that means that this one must also be 117. So we have opposite angles are congruent. I don't have enough space there, so I'm just going to use a symbol for congruent. So yes, it is a parallelogram. Okay. Picking out the easy one here. Opposite sides are congruent. So same here. If I do 360 minus 74 minus 74 minus 106, I am left with 106. So opposite angles are congruent. I'm just kind of skipping around. Sorry, I'm not going in a certain order. I'm kind of going some easier ones to some harder ones. All right. These diagonals are the same. These half a diagonals, I guess I should say, are the same. So that is reason number 4. The diagonals bisect each other. So yes, it is a parallelogram. All right, if I think of this bottom one here, I have 2 triangles. So I know a triangle must sum to 180. So what is 180 minus 30 minus 35? So that's 180 minus 65, which is what? 115. Do the same thing here. That also has to be 115. So now I have opposite angles because this is 75. This is 75. Or, sorry, 65. They're both 65. So, opposite angles again. All right. And then the last one is a little harder. It's not directly one of these, but it is also a yes because I have side angle, side, and then side, angle, side. Who knew that you would be doing that again? So that means that this angle is congruent to that angle, which would then mean this angle is congruent to this angle. So it's actually by the opposite angles are congruent. So option 3. All right, so you will be asked to prove which one it is in your activity. So make sure that you understand opposite sides, opposite angles, and bisecting. You could also be asked to do a little bit of algebra. So if I know that this side has to be equal to that side, that's exactly how I'm going to set it up. And then I'm going to solve by subtracting. So I have negative 8 equals negative 2x. Divide by negative 2 to get x equals 4. It says for what value of x is CDF a parallelogram? Well, that would be x equals 4. So yes, I have answered the question there. All right, and this very last theorem that I think I can cover in less than a minute. Sounds confusing. Says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. All that means, there's a lot of weird things that happen with the printing here, so none of that should be there. Just FYI. So we have these 3 little segments cut in equal parts of 2, 2, and 2. That means that all of these must be equal parts as well. So 2.5, 2.5, and 2.5. So when it asks to find EH, well, E is all the way down here, and H is all the way up there. 2.5 plus 2.5 plus 2.5 is 7.5. Easy as that. So make sure to try the practice on this one to understand your reasonings, why things may or may not be parallelograms.